Hello everyone and welcome back to my channel Be Yourself. This is Dr. Rajni Sharma, and in the series of enzymology I am discussing about the enzymes inhibitors. So in the last section we have discussed about the competitive inhibitors. We have seen that how our inhibitor compete with the binding site of the substrate or the active binding site of the substrate. In this section we will study about the uncompetitive inhibitor. In the last class also we have seen that how the kinetics of the enzyme will vary when competitive inhibitor will be there. So in this also we will also continue with the kinetics, that what will happen when the uncompetitive inhibitor will be there. Is it same as that of the competitive inhibitor or it will vary? Let's start with the uncompetitive inhibitor. In competitive inhibitor, what we have seen that the substrate and inhibitor were binding with the same site. But here in the case of uncompetitive inhibitors, first substrate will bind to the enzyme and it will form the enzyme substrate complex. After that, inhibitor will bind to the enzyme substrate complex and it will inhibit it to break down into the required product. So, basic difference between competitive and uncompetitive inhibitor is that in competitive inhibitor, enzyme and inhibitor were directly interacting with each other, or the inhibitor were able to interact with the free enzyme. But here in the uncompetitive inhibitor, as we have seen, it will bind to the enzyme substrate complex instead of the free enzyme. Now, how it will vary the kinetics of the enzyme? So here also we will consider the basic formula or basic steps which we have taken in the derivation of a Michaelis-Menten equation. So here also I will mention the same thing, that enzyme will bind with the substrate and it will go forward as well as it is able to go to backward direction, or it has the ability to reverse the enzyme substrate complex into a free enzyme and substrate. And if proper condition will be there, then enzyme substrate complex, instead of going backward with the equilibrium constant k minus 1, it will go forward to form the product with the equilibrium constant k2, and it will form free enzyme and the product will be released. Now here one more step I will add, that is in presence of the inhibitor, what will happen, instead of forming the enzyme E plus P, this complex will change into enzyme substrate plus inhibitor. So when there is a presence of inhibitor, but in absence of the inhibitor, what will happen, this enzyme substrate complex will go forward toward the formation of the product. If you will remember the derivation of the Michaelis-Menten equation, what we have done, we have taken there the total enzyme concentration at any time. So what we have seen, suppose E naught is the total enzyme concentration at any time, then what it will be? It will be some of the enzyme will be free, which will not be bonded to either the substrate or the inhibitor. So suppose this is the E is the free enzyme which has not bonded with any of the substrate. Some enzyme will be bonded with the substrate and some enzyme substrate complex will be bonded with the inhibitor. So how many enzyme species we have here for the uncompetitive inhibitor? We have in total 1, 2 and 3 enzyme species. Again go back to the competitive inhibitor and try to remember that what we have taken. If I will consider only this reaction where enzyme substrate is binding with the inhibitor to form the enzyme substrate inhibitor complex, or it may go reversible reaction to release the inhibitor to form the enzyme substrate complex. So in this case also what we will be having, this enzyme substrate will be having here the Ki constants, as we have represented here the K1 for the forward reaction equilibrium constant and K minus for the reversible reaction. Similarly I will represent here, just a second, I will represent here suppose Ki, equilibrium constant when the inhibitor is there, then Ki will be what? The Ki will be here reactant, and it is in presence of inhibitor. So I will just take, so what will be our reactant here? Enzyme substrate complex plus inhibitor. So here we have the two component of the substrate, which is I. So instead of taking the plus, we all know that while representing the chemical kinetics, we take it as a product of the substrate. So here enzyme substrate complex into inhibitor, or the concentration of inhibitor, by the product which is forming here. So what the product is forming here? Enzyme substrate inhibitor complex. So from this we can conclude the value for the enzyme substrate inhibitor. So if I will take this toward this side, so what we will be having for the value of enzyme substrate inhibitor? We will be having the value of enzyme substrate complex into the concentration of the inhibitor by equilibrium constant for when inhibitor is there. Now let us replace the value of ESI. So what will be the total amount of enzyme at any time when the inhibitor will be present? It will be equal to the free enzyme plus the enzyme which is bonded with the substrate plus this much value. So I will take this like enzyme substrate complex into inhibitor divided by Ki, which is the equilibrium constant when inhibitor is present. Now again, if you will remember, because here also we are following the same step of derivation of the kinetics which we have followed for the Michaelis-Menten equation. Only difference is that this enzyme, this inhibitor term, or this enzyme species is added here. So we will look for the free enzyme. What are the free enzyme present here? Again, I will go back to the equation which we are having with us for the Michaelis-Menten equation. If you don't remember, you can watch my previous video. So what we were having Km is equals to enzyme, free enzyme into substrate divided by our enzyme substrate complex, which has come from this equation, this initial equation, this much equation, if I will ignore the inhibitor one. To find out the exact value, how the Km value, how the velocity or the Vmax will vary, I will put this equation, suppose this equation 1, in this equation number 2, or in the value of Km. So here I am finding out the value of Km, and this will vary. How this will vary, we will look at this after putting the value of enzyme E. So from this equation 1, we can simplify the value for enzyme E. So what will be the value of enzyme E? It will be E naught, or the total enzyme, minus, I will take Es as a common, because this side, this whole term I am taking to this side, so this plus will become minus. And if I will take Es as a common, because here and here in both the cases Es is present, so I will take it like this, 1 plus I by Ki. So this equation becomes 3. Now from this equation, what I am going to do, I am going to put this value of enzyme value from the equation 3 to the equation number 2. So what we will be having, if I will replace this value enzyme from this equation 3, it will become Km will be equals to E naught minus Es into 1 plus I by Ki, and with this whole term substrate will be divided, multiplied. Sorry, here we have Es. Now we all know that the enzyme substrate complex is a very significant when we talk about the enzyme kinetics. This value, if it is a rate limiting reaction, then our whole kinetics will depend on the Es, concentration of the Es, or the rate of formation of the Es. So here now, just like the Michaelis-Menten equation, we will find out the value of ES. So very simple. So I like most these things, or simple thing in the mathematics, that for the value which you want to calculate, what you have to do, you just have to simplify the whole equation with respect to that term. So here I am looking for the ES. So what I am going to do, I am going to simplify this equation number 4 in terms of the ES. So I'm taking it a small space here, then I will go to the next page. It will be easier if I will calculate the value here. So what value we will get here? We will get Km into ES equals to E naught will be multiplied by this substrate value, substrate concentration, minus here again we have ES, and here only itself I am multiplying it with the substrate complex. It will be easier for me to write here 1 plus I by Ki. Now this value, now again what I am saying that I am going to calculate for this value. So what I will take this whole term toward this left hand side. So what I will be having, I will be having Km into ES plus ES into substrate concentration multiplied by 1 plus I by, or the inhibitor concentration, by Ki, and it will give to E naught into S. Okay, now finally I have got the value for the ES. So what will the value for the ES? If I will take the ES as a common, then I will be having Km plus substrate, but it will be multiplied by 1 plus inhibitor concentration by equilibrium constant when inhibitor is present there, equals to E naught into S. I am taking the another page. I will just copy this whole term in the next page. So I have copied the value which I have got in the last page here, ended here, and the next page. Now I am simplifying it for the term of ES. So what I will be having, I will be having E naught, or the concentration, total enzyme concentration, into substrate concentration, and when this term will go this side, right hand side, it will be go down here, and substrate 1 plus inhibitor concentration by Ki. Again remember, try to remember the derivation of Michaelis-Menten equations, where we have to calculate for the velocity. So what we have got the velocity, for the velocity we were having, initial velocity we were having K2 into ES concentration. So from this equation we have got the value of ES. So when I will multiply this K2 with this whole term, what I will be having here, for the initial velocity V naught, I will be having K2 into E naught into, or the total enzyme concentration into substrate concentration by Km plus substrate concentration into 1 plus inhibitor concentration by equilibrium constant when enzyme inhibitor is there. Okay, now again if you will remember the Michaelis-Menten equation, K2 into E naught was what? That was our V max. So I am going to replace this value with this V max. So what I will be having, I will be having the initial velocity of V max into substrate concentration by Km plus substrate concentration into 1 plus I by Ki. Now what I will do, I will multiply from, or I will divide the whole the term above or as well as downward with this value. So instead of writing this whole, what I am doing, I am just taking this whole value as a alpha dash, because alpha I have taken for the competitive inhibitor. In this I am going to take it as alpha. What will be the value of alpha? 1 plus I, or the inhibitor concentration by Ki. So this term I will use instead of using always this whole equation. Just to make it easier to write, I am going to take this whole term as a alpha dash. So I am going to divide the above term also with the alpha and this whole term also with the alpha. So what I will be having, I will be having the initial velocity V naught is equals to V max by alpha into substrate concentration by Km by alpha divided by alpha plus substrate concentration, because this term whole term is the alpha, and if you will divide this whole term with the alpha, then what we will be having, this alpha will be cancelled out. So finally what we got here, we got the initial velocity here as the V max divided by the alpha dash factor. So this is alpha dash, sorry, this alpha dash factor divided by substrate, and here also again Km factor divided by the alpha dash factor plus substrate concentrations. So in this way the whole system will be affected when the inhibitor is uncompetitive. So as in the last time we have done for the competitive inhibitor, we will convert this Michaelis-Menten equation formula into the Lin-Weber-Burg formula, or just by reverse. I will just reverse this formula. So what I will be having, I will be having 1 by V naught equals to, if I will simplify this, it will go Km by alpha divided by V max by alpha dash into substrate plus 1 by V max divided by alpha dash. Now this will be the our equation for the enzyme which will be inhibited by the uncompetitive inhibitor. Now let us see how it will affect the graph here. In a competitive inhibitor, what we have seen, only the Km was varying, that was going. So if this was the graph for the competitive inhibitor, not the uncompetitive inhibitor, then in the presence of competitive inhibitor, what we were having, the minus Km shifted toward the origin, or its value increased. So here what we are saying, here the Km as well as Vmax, both the value will be varying. So here the in the previous case, in the competitive inhibitor, what we were having, 1 by Vmax was not changing, but here the Km as well as Vmax is varying as per the derivation which we have seen just now. So now as per the equation, if you will plot the graph between the 1 by S naught, so again here, sorry, just like in the derivations, what we say that the substrate concentration is always very high concentration with respect to the enzyme. So we generally consider the substrate as the initial concentration of the substrate, because this will, if I will vary even a small amount of substrate, it will not affect the kinetics. But when the enzyme concentration will be decreased or increased, then it will vary. So we cannot take enzyme concentration always as a total enzyme, but we can take the substrate concentration as the total substrate present in the media. Now what we have seen, if you will plot the graph between 1 by S naught, or the substrate concentration, by initial velocity inverse of velocity, what we will be having, in absence of any inhibitor, we will be having this graph with this value minus 1 by Km, and this point will give the value for 1 by Vmax, and the slope we all know that it will give for the Km by Vmax. But in presence of the uncompetitive inhibitor, what we will see here minus Km will decrease by the factor alpha, and here Vm will also be affected by the factor alpha dash, I mean. But here the slope, if we will take the slope of Km by Vmax, the slope will not vary, because even if alpha dash factor will be here, it will be cancelled out. So it without affecting the slope, the value of Km Vmax will vary. So these were all about the uncompetitive inhibitor. In the next class, yes, one more thing, that if we will keep on increasing the concentration of the inhibitor, if this is inhibitor 1 and inhibitor 2, then we will see that the slope will go far away from the origin with respect to Km, and this 1 by Vmax value here will go up toward the y axis, and here the inhibitor concentration I is less than the inhibitor concentration 2. So as we will increase the inhibitor concentration, the Km Vmax will vary accordingly without affecting the slope value. So these were all about the uncompetitive inhibitor. In the next class, we will deal with the mixed inhibitor. It is very interesting because till now what we have seen is the inhibitor was either combining with the active site of the enzyme, or in uncompetitive inhibitor what we have seen, it was binding with either the enzyme substrate complex. But in this mixed inhibitor, the inhibitor has the tendency to bind with the just like that of the competitive inhibitor, as well as that like of the uncompetitive inhibitor. So if we will discuss about the equation which we are going to get, so here what we have here, enzyme substrate complex, it will form the enzyme substrate complex, and finally it will form the product. So here in mixed inhibitor, it will have the tendency to bind either with this point or with the free enzyme, and it will form the enzyme inhibitor complex, or it can also bind with the enzyme substrate complex also to form the enzyme substrate inhibitor complex, and in this way also it can also vary. So instead of having the 3 species of the enzyme, how many species we will be having? We will be having one free enzyme species, one, or total enzyme will vary how it will go like this, free enzyme plus enzyme which is bonded with the substrate, plus the enzyme which is bonded with the inhibitor, plus the enzyme substrate complex which is bonded with the inhibitor. So this is why it is known as mixed inhibitor, which has the mixed effect of both competitive as well as uncompetitive inhibitor. So in the next class we will see how the kinetics will vary in the mixed inhibitor. So don't forget to subscribe and share my channel, and till then, have a nice day, stay safe and be yourself.